NEC 230.71 first appeared in the 2014 National Electrical Code. The 6 disconnect rule in NEC 230.71 is not applicable to a single-family dwelling unit built in 1961 that has not undergone any electrical modifications to the junction box or panel. This is because NEC 230.71 applies to new installations and modifications made after the effective date of the 2014 NEC. The 6 disconnect rule is a requirement for junction boxes in accessible attics. Since the home was built before 2014 and has not been modified, it is not subject to NEC 230.71. To elaborate, the National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. It's updated every 3 years, and each edition incorporates revisions and additions to address new technologies, safety concerns, and industry best practices. Understanding the effective dates of specific code sections is crucial for determining their applicability to existing and new installations. The 6 disconnect rule, as it's commonly known, relates to the number of main disconnects allowed at a service entrance. This rule aims to limit the number of switches needed to completely de-energize the electrical system of a building, ensuring safety during maintenance or emergencies. Prior to the introduction of NEC 230.71 in the 2014 edition, the number of disconnects was governed by other sections of the code, which generally allowed for up to 6 service disconnecting means to be grouped in a single location. NEC 230.71 introduced more specific requirements and limitations, particularly concerning accessible attics and other areas where multiple disconnects might pose a safety hazard. The key factor in determining whether NEC 230.71 applies to a specific installation is the date of installation or modification. If an electrical system was installed before the effective date of the 2014 NEC and has not been subsequently modified or altered in a way that triggers the application of current codes, it is typically not required to be retroactively brought into compliance with the new requirements. This concept is often referred to as grandfathering, where existing installations that complied with the code at the time of their installation are allowed to remain in place even if subsequent code additions introduce stricter rules. However, it's important to note that any modifications or alterations to the electrical system after the effective date of the new code would typically require the entire system to be brought into compliance with the current code requirements, including NEC 230.71. In the specific case of a single-family dwelling built in 1961, if the electrical system, including the junction box and panel, has not been modified since its original installation, the 6 disconnect rule as defined in NEC 230.71 would not apply. The installation would be governed by the electrical code requirements in effect at the time of its original construction. It's also important to consider local amendments or interpretations of the NEC. Local jurisdictions may adopt the NEC with modifications or additions to address specific local conditions or concerns. These local amendments can affect the applicability of specific code sections and should be consulted in addition to the NEC itself. For example, a local jurisdiction might have more stringent requirements regarding the number of disconnects allowed or the locations where they are permitted. These local rules would take precedence over the NEC requirements. To determine the specific code requirements applicable to an electrical installation, it's always best to consult with a qualified electrical inspector or engineer. They can review the details of the installation, the date of construction or modification, and any local amendments to the NEC to provide accurate guidance on code compliance. The NEC is a complex and evolving set of standards, and proper interpretation requires a thorough understanding of its provisions and their application to specific situations. Incorrect interpretation or application of the code can lead to safety hazards and code violations. Therefore, it's essential to seek professional assistance when in doubt. Additionally, the NEC provides specific definitions for terms used throughout the code. Understanding these definitions is crucial for correctly interpreting and applying the code requirements. For example, the definition of service equipment is important in determining the number and location of disconnects required. The NEC also includes requirements for the type and rating of electrical equipment used in installations. These requirements are intended to ensure that equipment is suitable for its intended purpose and can safely handle the electrical loads imposed upon it. Compliance with these requirements is essential for preventing electrical fires and other hazards. Furthermore, the NEC addresses various aspects of electrical safety, including grounding, overcurrent protection, and wiring methods. These requirements are designed to protect people and property from electrical shock, fire, and other hazards. Adherence to these safety requirements is crucial for ensuring the safe operation of electrical systems. The NEC also includes requirements for specific types of occupancies, such as residential, commercial, and industrial buildings. These requirements address the unique electrical needs and hazards associated with each type of occupancy. For example, the NEC has specific requirements for the installation of ground fault circuit interrupters, or GFCIs, in residential bathrooms and kitchens to protect against electrical shock. Similarly, the NEC has specific requirements for the installation of emergency power systems in commercial buildings to ensure that critical loads, such as lighting and fire alarm systems, remain operational during power outages. The NEC also addresses the installation of renewable energy systems, such as solar photovoltaic or PV systems. These requirements cover the safe integration of renewable energy sources into the electrical grid. The NEC also includes requirements for the installation of electric vehicle charging equipment. These requirements address the unique electrical demands of electric vehicles and ensure that charging equipment is installed safely and in accordance with industry standards. Moreover, the NEC is not a static document. It is continuously reviewed and updated to reflect changes in technology, industry practices, and safety concerns. The NEC is revised on a 3-year cycle, with each new edition incorporating revisions and additions to address emerging issues and improve electrical safety. The process of revising the NEC involves a collaborative effort among electrical experts, industry stakeholders, and regulatory agencies. This collaborative process ensures that the NEC remains relevant and effective in addressing the evolving needs of the electrical industry. The NEC is also adopted and enforced by state and local jurisdictions. These jurisdictions may adopt the NEC in its entirety or with modifications to address local conditions and concerns. It is important to consult with the local electrical inspector or authority having jurisdiction or OJ to determine the specific code requirements applicable to a particular installation. The AHJ is responsible for enforcing the NEC and ensuring that electrical installations comply with applicable code requirements. The AHJ may also issue interpretations of the NEC to clarify its application to specific situations. These interpretations can be valuable in ensuring that electrical installations are installed in accordance with the intent of the code. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include standards developed by organizations such as Underwriters Laboratories, or ALL, and the Institute of Electrical and Electronics Engineers, or IEE. UL standards address the safety of electrical equipment and components, while IEE standards address various aspects of electrical power systems. Compliance with these standards can help to ensure the safety and reliability of electrical installations. Furthermore, the NEC is a valuable resource for electrical contractors, engineers, inspectors, and other professionals involved in the electrical industry. It provides a comprehensive set of standards for safe electrical installations and can help to ensure that electrical work is performed in a safe and code-compliant manner. The NEC is also a valuable tool for educating the public about electrical safety. By understanding the basic principles of electrical safety, homeowners and other individuals can take steps to protect themselves and their property from electrical hazards. This includes avoiding overloading electrical circuits, using properly rated extension cords, and never tampering with electrical equipment. Therefore, understanding the NEC and when each addition and revision become effective is essential to electrical safety. It is essential to determine if the jurisdiction uses the national edition or has amended it. This could change the applicability of certain rules. Consulting with the local authority having jurisdiction is the best way to ensure compliance. In summary, while NEC 230.71 specifically addressing the 6 disconnect rule, was introduced in the 2014 NEC. It generally does not apply retroactively to existing installations completed before that date, provided there have been no subsequent modifications. Always consult the latest NEC edition, local amendments, and a qualified professional for definitive guidance. Remember that electrical codes and regulations are in place to protect people and property from electrical hazards. Adhering to these codes and seeking professional guidance when needed are crucial for ensuring electrical safety. Finally, it's worth noting that the NEC is not intended to be a design manual. It provides minimum safety standards for electrical installations, but it does not provide detailed design guidance. Electrical engineers and designers are responsible for developing electrical designs that meet the specific needs of a project while complying with all applicable codes and standards. This often involves considering factors such as load calculations, voltage drop, and coordination of protective devices. Electrical design is a complex and specialized field that requires a thorough understanding of electrical theory, equipment, and codes. It is important to engage qualified electrical engineers and designers to ensure that electrical systems are designed safely and effectively.